Okay, right. So, welcome to our course R24 Manufacturing Process. So, this is similar. We already have a class called metal joining. So, right. So, this is a continuation class of metal joining classes. So, this is our content we are going to discuss. So, before start our content, we need to know introduction of welding. Right. So, the welding is a material joining process which produces collisions of material by heating them to suitable temperature with or without the application of pressure, or by the application of pressure alone, and with or without the use of filler metal. So it's a very simple. It is a metal joining process. It is used to join two metals, right? It is used to join the two metals with the help of pressure, or without help of pressure, or with the help of filler metal, or without help of filler metal. So main purpose is we need to join two metal with the help of welding. So it is used for making a permanent joint. So it is not a temporary joint. Temporary joint such as bolt, fastener, screw, these are the temporary joints. But permanent joint means you cannot dismantle very easily. If you want to disassemble, you need to break the joint. Then only you can disassemble. If you use temporary joints such as bolt and nut, you can unscrew your bolt and you can easily disassemble. But for welding, you cannot disassemble very easily. You need to destroy the welding, right? So we know that classification, we have a 7 classifications such as gas, arc, resistance, thermite, solid state, newer welding, and related process. So these are the subcategory of welding process. We have a gas welding. So in gas welding we have a 3 subclassification, and resistance welding we have five subclassification: thermite, solid state welding, newer welding called, it's a new technology, electron beam and laser beam. So related process is similar to our brazing and soldering, and arc welding. So now we are going to discuss arc welding and its types, right? So arc welding, so it uses an electric arc to coalesce the metal. So the joining is done with the help of heat. The heat is produced by the electric arc. Very simple. So this is similar. This is differ with resistance welding. The resistance welding, if the circuits are closed, then only electricity flow, electrons flow. If we insert in between this closed loop, the resistance will create. That resistance may generate temperature. That temperature is used to join two dissimilar metals or similar metal. Then we say it's a resistance welding. But arc welding, this is similar to electricity. So electron flows. If we close the electron, if we close the loop, that time the arc will generate. That arc is used to rise the heat. That heat is used to join these two metals. So uses an electric arc to coalesce metal. Arc welding is the most common method of welding metals. Electricity travels from electrode to base metal to ground. This is a very similar principle. So the main equipments. So arc welding, we have some similar set of equipments. The first one is a welding generator, DC or transformer AC. If we use DC welding, then we need to use generator. If it is AC welding, we need to use transformers. So the red color shows the power source, welding machine. It may be AC power source or DC power source. And we have two cables, right? One for to hold electrode, right? So one for electrode, another one for workpiece. So this is our source. We have a two cable, one for electrode and another one for workpieces, right? So the electrode, we have a electrode holder to hold the electrode. The electrode holder is attached to the electrode cable, and electrode holds the electrode. Similarly, the other cable, it is connected to the workpiece, and work is held with the work holding devices, right? So if we supply the electricity, right? If you supply the electricity, if the electrode touches the works, if electrode touches the work, then the arc will generate. This arc is used to rise the temperature. This is what arc welding. Alright, so for safety purpose, we need a protective shield, gloves, wire brush, chipping hammer, goggles, etc. So these are the main equipments. So we have a source. It may be AC source or DC source, and we have a two cable. One is a electrode cable, another one is a work cable. Electrode cable is connected to the electrode holder. Work cable is connected to the work holding devices. Work holding devices is a device which is used to hold the workpiece. Electrode holder is a device which is used to hold the electrode. So if you switch on our machine, the electricity will flow. If the electrode touches the workpiece, if the loop closed, then arc will generate. This arc is used to join the two metals. This is what a arc welding. Right, so we have two more types. One is a direct current, another one is a alternating current. So direct current, we have a two polarity. One is a straight polarity, another one is a reverse polarity. So direct current welding circuit may be either straight or reverse polarity. Direct current straight polarity, when the machine is set on straight polarity, the electrons flow from the electrode to the plate, right? So if it is a DCSP, DCSP stands for direct current straight polarity. So the straight polarity, the electrons flows. The only difference between these two, DCSP and DCRP, is the electron flow. If the electron flows from the electrode to workpiece, then we say TCSP. If the electrode flows from workpiece to electrode, then we say it's a DCRP, right? So for reverse, with reverse polarity, electrons is flowed from plate in the sense workpiece to electrode, then we say reverse polarity. So this is the straight polarity, electrons are reaching the workpiece, so the temperature rises more in workpiece, right? So but in reverse polarity, electrons reaching the electrodes, so the electrodes get more temperatures. For this reason, generally DCRP, direct current reverse polarity, uses a long diameter electrode cable. So it requires large diameter electrode than the DCSP. So this is what direct current straight polarity and then direct current reverse polarity. Okay. So alternating current, this is another one electric source. AC welding is actually a combination of DCSP and DCRP. So AC welding machines were developed with the high frequency current flow unit to prevent these rectifications. So generally it is used for high frequency. The high frequency current pierces means making a hole, punch. So the high frequency current pierces the oxide flames and forms a path for welding current to flow. So it will create the path, it will create the hole. That hole is used to pass the temperature arc. That arc is used to rise the temperature. That temperature is used to join two metals. So notice that ACHF offers both the advantages of DCRP and DCSP. So ACHF is excellent for welding aluminium. So aluminium, it is generally used for ACHF, alternating current high frequency. Right. So the difference between AC and DCR welding are, so source, we have a if we use a if we use AC welding, we need a transformer. If we do DC welding, then we need a generator, right? So AC from transformer, from generator for DC arc welding. Efficiency, if you compare efficiency, AC is more, DC is less. Power consumption, AC is less, DC is more. Cost of equipment, AC is less, DC is more. So voltage higher, hence not safe. So AC is the voltage is higher voltage, so it is not safe for our human. But DC arc welding, its voltage is very low, so it's a safe for operation. Connections, any terminal can be connected to the work or electrode. Right. Generally, we say anode and cathode. Anode means positive, cathode means negative. Generally, anode is used to connect the workpiece, but cathode is connected to the electrode. If you consider AC, you can connect anode as a electrode also. So you can connect. There is no rule. You can connect anything. So positive to workpiece or positive to electrode. So any terminal can be connected to the work or electrode. But if it is a DC, positive terminal means anode is connected to the work, negative terminal connected to the electrode. So welding of non-ferrous and ferrous metals not suited for AC but suited for DC. So welding thin sections not preferred in AC, but DC arc welding it is preferred. So this is what AC as well as DC welding. The next topic is fluxes. Right, the fluxes, we know the need of flux. The flux is used to generally to prevent oxidation. So after welding, the welded part should be in high temperature. It may react with atmospheric air. So it may make the atmospheric air contains oxygen. So it will form the oxide layers. To prevent these oxide layers, we use fluxes. So there are many types of fluxes available, such as manganese silicate. We can say it's a MS type. It contains a MnO, manganese oxide, and silicon oxide. Similarly, we have a calcium silicate, CS types. containing mainly CaO, calcium oxide, magnesium oxide and silicon oxide. Similarly, we have aluminum rutile AR type containing mainly Al2O3 titanium oxide. So aluminum basic types AB containing mainly aluminum oxide CaO plus MgO. Similarly, we have a fluoride basics FB type containing mainly calcium oxide, magnesium oxide and CaF2, calcium fluoride. So we have variety of fluxes available. In arc welding, we uses many variety. One is a manganese silicate, calcium silicate, aluminum rutile, aluminum basic types, fluoride basic. So MS, CS, AR, AB and FB. So generally fluxes are used to prevent oxidation. Right. So arc welding, the advantages are it is the most effective way to join metals, lower cost joining method, affords lighter weight through better utilization of material, joins all commercial metals, provides design flexibility, but we have some limitations. One is it is a manually applied, therefore the labor cost is high. Right. So it is manually applied. Most of the arc welding process can be applied manually, so the labor cost is high. Need high energy, so it may causing the danger, so it may hazardous to human, right? So not convenient for disassemble, right? Again, welding is not convenient for disassemble generally. Defects are hard to detect at joints, so we know that after welding maybe defects will occur. The identification of defects may be hard if you use arc welding, right? So the next topic is weld joints. Right, so we have a variety of weld joints. So here we listed only 5. We say butt joint. Butt joint means we place we use 2 workpieces to join So the both workpieces are in same line of action. So so we have a gap between this. This gap is filled with the help of a filler, or if you raise the temperature, the both the edges may weld. This is what butt joint, the same line of action, so it's a butt joint. This is a corner joint, so we may the 2 corners, it's like a L shape. If you want to weld L shape, we say it's a corner. This is a edge, so this is like if you want to weld this kind of joints, so you need to weld the top surface. This is what edge, so you can make a edge or you can make a corner. And if it is a lap joint, means the one workpiece is workpiece 1 and workpiece 2, we have 2 workpieces. The workpiece 2 is placed top of the workpiece 1, then we say it's a lap joint. This is like a T joint, so if you want to make a T shape, so then we use T joint. So these are the types of weld joints generally we use, right? So first we are going to see carbon arc welding. So this is up to this we saw introduction of arc welding and AC welding, DC welding. What are the advantages, disadvantages, what kind of fluxes we can use, all the introduction part will completed. Now we go with the carbon arc electrode, carbon arc welding. So the name implies that carbon arc welding, right? So arc, we know that arc means, so if you pass electricity, the loop, if the loop closes or if the electrode touches the workpieces, then arc is created. So arc welding, this is a basic principle. And we use carbon as the electrode, then we say it's a carbon arc welding. So carbon arc welding is a process which produces collisions of metal by heating them with an arc between a non-consumable carbon electrode and the workpiece, right? So this is one of the difference. So we use electrode, that electrode should be the non-consumable, which means the filler, we never use electrode as a filler metal, right? So the joints are done with the help of the base metal or parent metal itself. So this is what carbon arc welding, this figure represent the carbon arc welding. It's a very simple diagram. So we have a source, power source, it may be AC or DC, and we have 2 cables. The one cable is connected with the workpiece, another cable is connected with the electrode. This is a carbon electrode. If you supply the electricity, the electrode touches the workpiece, then it will create the arc. That arc is used to join 2 metals. That's it. A very simple process. So advantages are high input to the workpiece can be easily controlled by changing the arc length, right? So you can change the arc length, so that you can tilt electrode, or you can increase the gap between workpiece and electrode so that you can change the arc length. So it is controlled very easily. The second point, workpiece distortion is negligible. So definitely the distortion may happen. So it will generally negligible amount only. So third one, welding cost is less as compared to other welding process. Equipment required for carbon welding is simple and easily available. These are some of the advantages. Similarly, we have some limitations. The one is there are chances of carbon being transferred from electrode to weld metal, thus causing a harder weld deposit in case of ferrous metals. So this is what they say. We use non-consumable electrode. As per rule, non-consumable electrode doesn't deposit to fill the gap, but sometimes carbon may be transferred. So this will cause the harder metal at one particular place. So this is one of the disadvantages. The second, in absence of proper electrode geometry and in confined spaces or below, results which gives poor welds with blowholes and porosity. So we need to use proper carbon electrode size and shape. So if we didn't use proper size and shape, the weld joints are higher, or the weld peak are higher in some place, weld peak are lower in some place. It may differ. The third one is a separate filler metal is needed because we use non-consumable electrode when used to slow down the welding speed. So if you use filler metal, then the speed of the weld may be reduced. So these are some of the disadvantages. So the applications are carbon arc welding process can be used for welding steel, aluminium, nickel, copper and a good number of other alloys. So we can weld variety of weld materials. The second one is carbon arc can also be employed for brazing, preheating and post heating of the welded joint. So generally carbon arc is used in brazing also for preheating purpose. The third one, carbon arc welding can be used for repairing castings. So we make product with the help of casting. Sometimes it may get some defects, casting defects. That defects we can rectify with the help of carbon arc welding. On many applications, however, carbon welding has been replaced by TIG welding. So sometimes most of the applications the carbon arc welding is replaced by TIG welding. These are some of the applications. Right. The second types of arc welding is metal arc welding. So previous case we say carbon arc welding, which means electrode as the carbon, it's a non-consumable. Here metal arc welding, the name. So the electrode as a metal. Right, the metal as a electrode, it is a consumable electrode. The difference is there non-consumable, they are consumable electrodes. So again, this is similar to our normal arc welding. Only thing is we use metal as a electrode. That metal is generally similar to base metal. So base metal means what are the metal we are going to do weld. So for example, we have two work pieces. If the two work pieces are assumed that it may be the mild steel, then the electrode should be the mild steel. Because the electrode is a consumable electrode, so it acts as a filler metal, so it will melt and it will deposited between these two between the gaps of two work pieces, so it should same as a parent metal. Right, so we have a flux and this image represents the metal arc welding. Here we have a workpiece and we have a welded part. So weld is moved from this direction, so from left to right. So this is a welded part, and we have we use some fluxes to prevent oxidations, and we have a slag over there. So some slags are solidified after for heating. This is a molten state and workpiece. So we use some gases also. Right, so to strike the electric arc, the electrode is brought into the contact with the workpiece by a very light touch with the electrode to the base metal, then is pulled back slightly. So this is what similar. So arc is generated if you touch electrode in the workpiece. So if you touch the electrode and the workpiece, then only the arc will start. So here we touch electrode, slightly we touch electrode, we slightly touch workpiece, the arc will generated. So this is what happened. This initiates the arc and thus melting of the workpiece and the consumable electrode, and causes droplets of the electrode to be passed from the electrode to the weld pool. Right, so this is what a similar process. As the electrode melts, the flux covering disintegrates, giving off shielding gases that protect the weld area from atmospheric gases. So here we use some atmospheric gases. Right, so we use some atmospheric gases to prevent oxidations. So generally we say it's a shielding. Shielding means it's a covering or safer. Shielding gas. In addition, the flux provides the molten slag which covers the filler metal as it travels. So So in order to prevent oxidation, we use flex also. Once part of the weld pool, the slag floats to the surface and protects the weld from contamination as it solidifies. This is what metal arc welding. So the next part is gas metal arc welding. So this is similar to metal arc welding. Only difference is the electrode is surrounded by the atmospheric air. Here the electrode is surrounded by the some specified gas such as inert gases like argon, helium, carbon dioxide or other gases. This is what inert gas. So gas metal arc welding is a metal inert gas welding. It uses again consumer electrode because here we use metal as an electrode. The filler wire is supplied from a spool. So weld area shielded by an effective inert atmosphere of argon, helium, carbon dioxide and various other gas mixes. So GMAW process is suitable for welding a variety of ferrous and non-ferrous metals. Right, so it is a process versatile, rapid and economical. Welding productivity is double that SMAW. SMAW stands for submerged arc welding. Right, submerged arc welding. It is a productivity is twice compared to submerged arc welding. This is what gas metal arc welding. So the metal is how we transfer the metal. Right, so the consumer electrode. It can be transferred by three methods. One is a spray, globular, short circuiting. Right, so spray, so generally we use water spray. So it's like metal is transmitted or metal is deposited as a spray. Sometimes metal is transmitted as a globular, long droplets or one big droplets. Short circuiting means it is like a small droplets, right? So right. So spray transfer results in weld beads with a minimum spatter, deep penetration and a smooth weld bead. So this is the image shows the spray transfers. So the electrodes, the metals are deposited as a spray. So teeny spray, right? So globular transfer occurs with a higher voltage setting than the short circuiting circuit. So the three transfers are based on the voltage setting, right? So for minimum setting we can get spray transfer. If it is higher setting, we say it's a globular. Somewhat minimum, somewhat higher, then we say it's a short circuiting. So occurs with a higher voltage setting than short circuit transfer, and the results are deeper penetration with a flatter weld bits. So short circuit results in a smooth weld with shallow penetration that easily bridges gap or poor fit by process capabilities. So this is what the metal transfers. Right. So this is the equipments we use for gas metal arc welding. First one is a source. Right. So we need a source. So this is what a source or control unit or welding machine, right? So the welding machine is connected to the control systems, feed control system. So the feed control means we need to feed the electrode, filler metal, right? Metal as a wire. We will fill the metal as a wire. So that feed of wire is controlled by feed control, and we have a one part is connected to the workpiece. Another part is connected to gas input, because gas metal arc welding the electrode should surrounded by the inert gas. So it is stored in the separate cylinder. That cylinder is controlled by machines, right? So this is a welding machine or source. We have three connections over there. The one is connected to the workpiece. The first one is connected to the workpiece, and the second and three are connected with the control system. That control system is connected with the two controls. One is a gas control, another one is a wire control. So if you start the machine, the wire is fed, and the workpiece is holded. If you pass electricity, the gun is get its arc. It will then the wires are transferred as a metal droplets or spray or globular. It may deposit it over the workpieces. This is what gas metal arc welding. Right. So advantages are joints can be produced with a deep penetration. Thick and thin metals are welded very effectively. This welding process is very suitable for large scale production unit because it can be performed much faster than the other types of welding process like TIG. Right. So this is generally used for large scale production because the productivity or the speed of weld speed is high compared to other process. Right. So large amount of metal can be deposited on the workpiece. MIG welding process can reduce the welding cost because it produces the neat and clean weld metal weld workpieces and sputter. So again GMW, gas metal arc welding, is also called as a MIG welding, right? So MIG welding. So applications are, it is used for mainly used in automobiles, industry, aircraft parts, welding, pressure vessels, manufacturing, and many other places. So this is what general applications. Right. So the next topic is Flexcore arc welding. We say it's a FCAW. Flexcore, which means we have an electrode. The electrode is coated with the flex. The flex is a agent which used to prevent oxidation, right? So this is similar to our metal arc welding, right? So the Flexcore arc welding process is a modification of MIG welding process in which solid wire is replaced by a flex cord electrode wire, that is a tabular wire filled inside with the flex and alloy additionals. In many cases, right? So the Flexcore arc welding. So in many cases, the flex cord wire alone produces a weld equal to or better than the original metal, and it's used to eliminate the need for gas sealed equipment and cost of the gas. So generally, it is similar to metal arc welding. Only difference is the electrode is coated with the flexes. So commonly, it's a flex cord. Flexcore arc welding is similar to the gas metal arc welding. Electrode is tubular form, is filled with the flex. Cord electrodes produces more suitable arc, improves the weld contour, and produces a better mechanical property. Flex is more flexible than others, right? So this is what a Flexcore arc welding. So the figure represents the Flexcore arc welding. Only difference is we have a nozzle over there. In nozzle we have a one tube is there. The tube is nothing but our electrode. The tube is coated with the flex. So the welding off due to so while weld, the flex is deposited over the molten weld. So this is what Flexcore arc welding. So advantages are high quality weld is produced, high deposition rate, reduced distortion than SMAW. SMAW stands for submerged arc welding. These are some of the advantages for Flexcore arc welding. So we have some limitations. One is used only to weld ferrous metals. Electrode wire is more costly than solid wires. Expensive equipment, right? So these are some of the limitations. The next one is applications. Generally, shipbuilding, tractor frames, large gantry cranes, bridge graders. These are some of the applications for Flexcore arc welding. And the next topic is tungsten inert gas welding. So this is the name implies carbon arc welding means we use electrode as a carbon. So tungsten inert gas welding means we use tungsten as a electrode. Inert gas means the electrode is surrounded by the inert gas such as argon, carbon dioxide, etc., helium. So in arc welding, coated electrodes are used to protect an envelope of gas are formed around the weld zone to prevent from atmospheric oxygen and nitrogen. So this is what like a flex cord. So the electrode is coated with the fluxes, right? So in TIG welding, inert gases are used. So generally we use fluxes to prevent oxidation, but TIG welding we use inert gas as the preventing material. The arc is maintained between the tip of tungsten. It's a non-consumable. So tungsten is a non-consumable electrode and workpiece. The filler rod is additionally added to the weld joints. In this process, AC or DC may be used. Alternating current or direct current may be used, which depends on the type of metal to be welded. So based on our workpiece material, we need to choose our welding source. It may be AC or DC. The DC with straight polarity used for welding a copper or its alloys, stainless steel, and reverse polarity used for magnesium. So if you use DC, straight polarity used for copper, stainless steel, etc. If you use reverse polarity, generally it is used to weld magnesium. The AC used for welding steel, cast iron, aluminium, and magnesium. So these are some of the types of tungsten inert gas welding. The advantages are it is better controlled by welder, because it's clean visibility of produced arc and melting base metal. So it is visible. It can be viewed by the worker, so we can easily control. The second one is high quality of welding is obtained on thin metal from TIG welding process, and the third one is no flex inclusion is welding joint. So we never use flex, and minimum cleaning is required after welding, because we never use flex. Instead of flex, we use inert gases. Right, so applications are welding of sheet and thinner sections metals, spaceship vehicles, motor chamber welding. It can be used to weld copper, aluminium, nickel and their alloys, zirconium, titanium, etc. and welding of bellows, instrument diaphragms, transistor cases, joints. These are the some other applications we can weld with the help of tungsten inert gas welding. Okay, the next is atomic hydrogen welding. The name implies that atomic hydrogen, but here here the temperatures are generally not created with the help of electrode, right? So in atomic hydrogen welding, the workpiece may not be the part of electrical connection for completing electrical circuit. So again, this is what we have a electrode. We have two electrodes, right? So it is surrounded by the one nozzle or notch, and the hydrogen is circulated in between this nozzle. The hydrogen, if you supply the electricity, the hydrogen H2 will split as a H plus molecular atomic hydrogen. So this atomic hydrogen is unstable. It may be joined again. So this joining may rise the temperature. That temperature used to join two metals, right? So atomic hydrogen, the arc is produced between two tungsten electrode. The molecular hydrogen, when passed through the electrical arc, is broken into atomic hydrogen formed by absorbing the energy supplied by the arc, right? So if you supply the H2, it will absorb the energy created by the electrode, and the H2 is split as the atomic hydrogen, AH plus. So atomic hydrogen. The atomic hydrogen thus formed is unstable and has a tendency to revert back to molecular state. So the H plus, it's unstable, so it always to make H2 it join. So this recombination takes place at comparatively lower temperature zone outside the arc boundary. The recombination is an exothermic reaction which liberates the large amount of heat, approximately temperature 3730 degrees Celsius. Right, so this is a very huge temperature. So this heat with the arc is used for creating the joints. This is what atomic hydrogen welding principles. The next is plasma arc welding. So arc plasma is a temporary state of gas. Again, it is one kind of gas. It is a unstable gas. The gas gets ionized after the passage of current and it becomes a conductor of electricity. If you supply the electricity, the gas may convert as the ionized state. Ionized state means high energy state. So this energy creates the temperature. The ionized gas atoms break into the ions, electrons and highly excited atoms. So this is what plasma arc welding. A non-consumed tungsten electrode as a cathode and water-cooled copper nozzle as an anode is used in this welding process. Right. So this is we use the black color. The black color is the electrode. It is tungsten electrode. It's a non-consumed electrode. The tungsten electrode is in between the nozzle. The nozzle is made by the carbon, right? The carbon, and it is surrounded by the water. And we pass plasma gas in between this nozzle. So this gas, if you supply electricity, it will get ionized state. So the initial arc is ignited with the high frequency arc. A pilot circuit is used to produce initial ionization for the plasma jet. The water cooling for the torch body must be provided for sufficient cooling, otherwise premature overheating will occur. The arc is compacted with the help of small diameter nozzle which squeezes the arc, increase the pressure, temperature and heat intensity. The stable arc is obtained. So the energy of the plasma jet and the temperature is dependent on the electrical power used to create the plasma. So the nozzle is used to generate focused beam. Right, so focused beam. The energy is depends on the power of electricity. Right, so electrical power. Right, so if you have two types of torch we use, one is a transfer arc torch, another one is a non-transfer arc torch. So this one is the transfer arc torch. Right, so non-transfer arc torch. So non-transfer torch means the arc is produced between the tungsten electrode and the water-cooled nozzles. Right, so the arc is produced between tungsten electrode and water-cooled nozzle. That is what non-transfer. Otherwise, if the arc is produced between electrode and workpiece, then we say it's a transfer arc torch. In the transfer arc torch process, arc is produced between the workpiece and electrode. Right. So this is what transfer and non-transfer is. So advantages are it has excellent weld quality. Arc is stabilized. It needs very simple type fixers. So very simple type of holding. Root welding is not required. Penetration is uniform. It produces a radiographic quality welding. Applications are nuclear and submarine pipe welding is done. Welding of aerospace component, nickel and high nickel alloy welding, melting the high melting point temperature metals, titanium belt welding up to 8 mm thickness, welding the stainless tubes up to 1/4 of thickness, right? So this is half quarter inches thickness. So these are some of the applications of plasma arc welding, right? So the next process is submerged arc welding. So this is, we generally say submarine. Submarine means the vehicle is traveled inside the water. Similarly, submerged arc welding means we have a flux, so the arc is generated inside the flux. We cannot view the arc. So this is what the image it represents. So we have a source, right? So this is what a voltage and a current control, and we have a flux cooper, right? So cooper is one of the storage device. So we insert our flux in the cooper, and the cooper is it is connected to the nozzle. So the flux is transferred and it is deposited over the workpieces, right? And we use some consumable electrodes. That consumable electrodes, it is in the wire form. It is in the spool, filament of spool. So it is transferred and it is supplied to the workpiece. And we use electricity. We pass the electricity. So the arc is created. The arc is melts the consumable electrode, and the consumable electrode deposits over the workpiece. The flux is placed top of the welded metal piece. So we cannot view the arc. The arc is produced inside the flux. So the unused fluxes are again it is taken with the help of other devices. So it is a recovery tube, unfused flux recovery tube. It is like a suction. So we have a pump over there. It sucks the unused fluxes, and again unused fluxes are again we can use in next time also. So this is what a submerged arc welding, right? So this is our workpiece, and this is a welded part, unused welded part, and then this one is a molten flux, and we use fluxes. Some of the fluxes are molded, unused fluxes are taken from other devices, right? So arc is set up between bare electrode and workpiece. The electrodes will be bare, which means there is no coating, right? So the arc end of the electrode and molten pool remains completely hidden under the blanket of flux. So it is hidden. We cannot view. The arc is we cannot view. Weld arc is shielded by the granular flux consisting of silica, lime, magnesium alloys, oxide, calcium fluoride, and other components. So in beginning we saw some types of fluxes. So it may be used as any flux. The flux is fed into the welded zone by gravity flow through nozzle, and thick layer of flux covers the molten metal. So the flux acts as a thermal insulator, promoting deep penetration of heat into the workpieces, right? So consumable electrode is a coil of bare round wire feed automatically through the tube. So power is supplied by the 3-phase or 2-phase power lines. The unfused flux is recovered and reused. This is what submerged arc welding. The advantages are high deposition rate. The heat can be concentrated to weld thicker section with a deeper penetration. Higher deposition rates may be possible, and due to the higher deposition rate, the number of passes may be reduced. Welding is carried out without the spark, smoke, flash, or spatter. Disadvantages are, since the operator cannot see the welding, he cannot accurately judge the progress of welding because the arc we cannot view. The process is limited to flat position and to metal thickness greater than the 4.8 m thick. So applications are a fabrication of pipes, pressure vessels, boilers, bridges, graders, shipbuilding, automotive industry, and rebuilding of worn out parts, etc. These are some of the applications of submerged arc welding. Alright, so the next process is electrogas welding. Generally we say EGW, electrogas welding. So it is a welding process. It is generally used to weld edges, right? So edges of sections vertically in one pass with a piece of placed edge to edge, right? So this figure represents the electrogas welding. Here we have a two shoe. One is it's like a machine vise. So this is a fixed shoe. Another one is a movable shoe. Both are controlled by water. The temperatures of shoes are controlled by water. So we have two nozzles are there. One is water in, water out, water in, water out. The movable shoe, it can move, and it can move depends on the size of the workpiece. The green color, it's a workpiece, right? So we connect to the gas, right? So it's a gas. We connect to the gas. We use two gases. One is a primary gas, another one is a secondary gases. So this is a primary shielding gas and secondary shielding gas. Primary gas is supplied to this here. So we have a nozzle, electron nozzle, and it is controlled by water cooled. And this is a wire electrode. It is a wire form, and it is fed to the nozzle. It is an oscillator, it may be optional. So we place, this is our workpiece. So if you pass on the electricity, the arc will created, and we pass the gases, so it will create the arc and it will join the metal pieces. So it is a section vertically in one pass with a piece of placed edge to edge. Weld metal is deposited into weld cavity between two places to be joined. The arc heat melts the electrode and the groove faces of the workpiece. The molten pool thus formed remains confined between two water-cooled sews. So we use two sews. One is a fixed sew, another one is a movable sew. As the molten metal solidifies, the sew moves upward and the welding head. Single and multiple electrodes are fed through the conduit and continuous arc is maintained using a Flexcore electrode up to 750 ampere, right? So the welding area is purged into the shielding gases. This is what Electroglass welding. The next process, Electro Slag welding. So the figure represents the Electro Slag welding. This is also called as a progressive process. Why we say it's a progressive means the solidification done with the help of solidification from bottom to upward, right? So this is the green color represents the workpiece. We place our workpiece like this. So and we insert this wooden piece. So both the gaps should be in gap we place our wooden stool, and so similarly we have a power source. The power source, we connected three power source. One is from power source we have a three cable. One is connected to the electrode, another one is to workpiece, another one is to the control panel, right? So the control panel means wire feed control. So we have a consumed electrodes over there. So if the consumed electrodes are connected with the nozzles, and it will deposit it over the workpieces. So the bottom, first the bottom is solidified. Bottom is we deposit the material and it moves upward. So the nozzles moves upwards. So the solidification takes place from bottom to top. This is what Electro Slag welding. A piece of steel wool is placed between the electrode and the workpiece to produce an arc. Some amount of flux is added in the produced arc and it melts with the heat of arc. The electrical arc is stopped when the sufficient amount of molten flux or slag is produced. The electrical current is passed through the molten metal of slag. The molten slag is sufficient to melt the filler metal and the workpiece. The electrode melts and fuses the base metal, also producing a weld bed. Thus, the Electro Slag welding is a progressive process of welding and solidification from the bottom to upward. So this is what the fluxes are used to product the oxidation. This is what Electro Slag welding. So advantages are it can be used for welding workpiece up to thickness 45 centimeter. No need of special edge preparation. It gives spatter free, right? So it gives a spatter free weld joint. Welding in the flat and overhead position is possible. High deposition rates. So we can reduce the number of passes. So limitations mean tend to produce a larger grains. Welding is carried out in a vertical uphill position. Tendency to hot cracking in HA. HA stands for heat affecting zone, right? Heat affecting zone. So applications are many range of alloys materials can be welded successfully. So the difference between Electro Slag and Electrogas weldings are Electro Slag, it uses the electrical resistance of a molten slag bath to convert electrical energy to thermal energy. Electric arc is there during welding. So this is similar to our submerged arc welding, right? So the electrical it uses electrical resistance molten slag bath to convert electrical energy to thermal energy. But Electroglass, it is obtained by the electrical arc. So here we can't view the electrical arc. Generally, it is done by the Electro Slag. Weldable is sealed by the molten slag. So this is sealed by the molten slag, but here we use some inert gas like carbon dioxide, helium, argon, like that. So we can use AC or DC if you use Electro Slag, but Electroglass you can use only DC. So DC alone we can use, right? Okay. Thank you.